We are learning motion in one dimension, and this is note number 2. We'll be seeing about rest and motion. Okay, we'll be studying about rest and motion. You know that every object in the universe is in motion. Okay, any form of motion. Every object in the universe is in motion. We see birds flying, they are also in motion. Then even our solar system is in motion, right? All the planets revolving around the sun. So every object in the universe is in motion. We also see people walking, right? They are also in motion. We see insects or butterflies flying, right? So although nothing is at rest, but we often say that a stone lying on the ground is at rest. Why is it so? Even though nothing is at rest, but then we say that a stone that is lying on the ground is at rest. Now, why do we say that? The reason is because the stone does not change its position, right? That's the reason, because stone does not change its position. It remains in the same place. Similarly, if we are sitting on a railway platform, I hope most of you have had this experience, and when you're sitting on a railway platform and look at a tree nearby, okay, remember that you're sitting on a railway platform, we say that the tree is at rest, right? When we look at a tree nearby, we will say that the tree is at rest. Why do we say that the tree is at rest? Because it does not change its position with respect to us, because the tree is not changing the position respect to us. And when we see a train leaving the station, okay, some of us, we enjoy looking at the trains, and when we see the train leaving the station, we say that the train is in motion. Why do we say that the train is in motion? Because it is continuously changing its position with respect to us. That's why we say that the train is in motion. Okay? Now let us understand it much further. A body is said to be at rest if it does not change its position with respect to its immediate surroundings. Alright, I hope you understand this, right? And while a body is said to be in motion if it changes its position with respect to its immediate surroundings, right? So this is the difference between the body which is said to be at rest and the body which is said to be in motion. Like for a moving body, if the distance traveled in a certain time interval is much large as compared to the size of the body, okay, as compared to the size of the body can be assumed to be a point particle. Remember this term, okay? A body can be assumed to be point particle. Now let us understand much more about one-dimensional motion. One-dimensional motion. Let's say there is a car and this car has to travel on that straight path. Okay, the car has to travel on that straight path. Now we have learned that a straight path is one-dimensional, right? One-dimensional. That's what is a straight line, a straight path. And when a body moves along a straight line path, okay, when a body moves along a straight line path, its motion is said to be one-dimensional motion. I hope you can understand this. I hope you get this. When a body moves along a straight line path, its motion is said to be one-dimensional motion. Okay, now we have other terms for one-dimensional motion also. It can be also called as rectilinear motion. One-dimensional motion can also be called as rectilinear motion. Let's say that a stone is vertically falling downwards. Okay, a stone is vertically falling downwards. You can notice, you can see on your screen that it's a straight path, a stone falling downward vertically. Like I said, that there are some other terms that we use for one-dimensional motion. The other term can be a straight line motion, and we also talked about that it is also known as rectilinear motion. Now in one-dimensional motion, there is no movement of the body in lateral direction. Okay, now what is this lateral direction? That means no sideways motion, only straight path, straight line. Okay, so in one dimension motion there is no movement of the body in lateral direction. Like you can see, movement on a straight path, movement on a straight line, a straight line. Now this is one dimensional motion. But on the other way, when we talk about sideways, like you can see on the screen, this is not one-dimensional motion because it is lateral direction, right? So one-dimensional motion, in one-dimensional motion, there is no movement of the body in lateral direction. Let's talk about a body moving along the curved path. Okay, along a curved path. Now if a body moves on plane along a curved path, its motion will be known as two-dimensional. Okay, two-dimensional motion. Now you remember, when a body is moving along the curved path. Now if an object is moving in space, like I said, if a body moves in space, its motion is three-dimensional. Okay, free space, its motion is three-dimensional. So here I have tried to explain to you about two-dimensional and three-dimensional, but in this chapter we will learn only the one-dimensional motion. We will only be learning about one-dimensional motion in this lesson. I hope you have understood till here. We're learning the lesson motion in one dimension, and we'll be learning about representation of one-dimensional motion. The path of one-dimensional motion can be represented by a straight line parallel to the x-axis if x-axis is taken in the direction of motion. Okay, and each point that I am marking here, that you can see on the screen, each point on the straight line, it represents the position of a particle at different instants. Okay, at different instants, at different points. So the position of particle at any instant, we'll mark it with t, small letter, is expressed by specifying the x coordinate at that instant. X-axis, you know that it's a horizontal mark, horizontal line, right? So instant is referring to that point. We'll just see an illustration here. Okay, suppose if we have to measure the position of the pebble measured from its starting point falling freely vertically downwards. Okay, remember this, at different instances. X resembles the position of the pebble and t resembles the time. So x here is 0, the first one that you saw. That means the initial position, where time is 0 seconds, right? And at the second mark that you see there, the second instant, the position marked with x is 5 meter and the time is 1 second, right? So the time is 1 second and it took within 1 second it traveled 5 meter. The third instant, at third instant, that would be 2 seconds, right? Now in 2 seconds the pebble travels 20 meters. And the fourth mark that you see there, it represents 3 seconds. T is 3 seconds. Within 3 seconds the pebble travels 45 meters, and the last one, that is our fifth point, right, that will be 4 seconds. So at t, which is equal to 4 seconds, x is what? X resembles the position of the pebble. That means by 4 seconds the pebble has traveled 80 meters from the initial point, right? Now here you will see a table on your screen, right, that is representing the time and the position of the pebble that is falling freely and vertically downwards, right? The time t and position is represented by x. So time is taken in seconds, that is represented by s, and position is measured in meter. So here it is written as small m. So I will just write it down in this scale, okay, in this table, so that you can understand it much better. Initial point, right, initial position, the time, initial time was 0 second, and the position, of course, it will not move, so it was x is equal to 0. The second one, in 1 second, the position of the pebble was 5 meter downwards, right? It's falling freely and vertically downwards. And the third box that represents at t, which is 2 seconds, the pebble has covered 20 meter distance. And the fourth box that you see that represents 3s, 3 second, the pebble has traveled 45 meter, and the last one, time, is 4 seconds, and position of the pebble is 80 meter, right? I hope you can understand this. And this is the representation of one-dimensional motion, okay? It is a representation of one-dimensional motion. And here the x-axis represents the vertical downward direction, okay? I hope you can remember this. The straight path, the straight line that you see, one-dimensional motion. So straight line along x-axis, that represents vertically downward direction. I hope you have understood this. Let us understand about distance and displacement. Okay, distance and displacement. Now let's take a point A and the other point is B. Let's say that point A is the initial point and point B is the final position or final point, and that dotted red line that you see there is a straight path. Suppose if a person wants to travel in a not a straight path, right? Suppose a person just wants to diverge his or her path, that is marked by the black color that you see there. So the total length of path from A to B, the total length, right, the total length from A to B is called the distance moved by the body, the black mark that you see there, right? The next one is the length of a straight line AB in direction from A to B. That is called the displacement of the body. That is shown by the red dotted line here. The straight line, the straight path. Okay, that is what displacement is. Let's define distance. Okay, let's define distance. The total length of path through which a body moves is called the distance traveled by it. The total length of path through which a body moves is called the distance traveled by it. And the distance traveled by a body depends on the path followed by the body. Okay, the distance traveled by a body depends on the path followed by the body. Like I will show the illustration again. Point A is the initial position and point B is the final position, and here you can see that the distance traveled by the body depends on the path followed by the body, right? It's not the straight path. And you also remember that distance is a scalar quantity and is represented by letter S. The SI unit of distance is meter, represented by small letter m, and CGS unit is centimeter, represented by small or lowercase cm. Let's see the definition of displacement. Definition of displacement. It is the shortest distance from the initial point to the final position of the body. Right? It's the shortest distance from the initial to the final position of the body, and is the magnitude of displacement, and its direction is from the initial position to the final position. So this is the definition of displacement, and I hope you can remember and understand this. Let me show you an illustration here. The initial position A and the final position is B. The shortest distance between the initial position and final position, right? That is what is referred to as displacement, right? The shortest distance from A to B, or the shortest distance from the initial position to the final position. Displacement is a vector quantity, and it is represented by capital letter S with an arrow sign on top, and the SI unit of displacement is meter, represented by m, and CGS unit is centimeter, represented by lowercase cm. I hope you have understood the lesson till here. Keep studying and keep learning. You can keep revising. You can go through the video and revise it again and write notes. Keep learning.